All right. Now, if you have a sun, a planet moving around the sun, right? But then the sun is moving around the galaxy. That's a larger spiral, because the galaxy is moving through space. And then the galaxy is orbiting a cluster of galaxies. That's moving through space. And then that cluster is orbiting a larger cluster, which is orbiting the universe, which is a larger spiral, and that universe is orbiting a multiverse, a larger universe, and a larger universe, and a larger universe to infinity. That's where the fractals become a really good thing to have. Because in an infinite fractal of rotation, in an infinite fractal, how do you define the center? Every point is the center. You are the center of the universe, or observing the universe from your very own center. Wherever you pick a point of observation in the fractal, that point becomes the center from which you're observing the universe. That point becomes stillness. Why stillness? Because in that point now, all of the spins of the universe cancel out. For each spin you find, you'll find in the universe an exact and opposite counterspin. So all of the spin canceling out in each point creates stillness. I'll give you an example. Here's a hurricane off the coast of Florida. How many, 100 miles an hour wind, 100 plus an hour wind, right? What's in the middle? Stillness. The eye of the hurricane. You need stillness to be able to have a frame of reference for rotation. You see? And that is how singularity occurs. Singularity is the point at the center of your experience of the universe, that's the point of stillness from which you're observing the universe. This is why, I say the universe is a fractal structure, and then people say, well, if that was true, we would all look the same. Well, we don't all look the same. Why? Because we're observing the universe from our particular point of stillness, our particular point of center. If we all observe this pan from our particular point of center, that means we're all going to get a whole different set of information about this pen. And because we all get a different set of information, we all look different. Can you guys understand? Do you guys understand this? Right. So it's all spin canceling in the middle of all things, creating stillness. From that point of stillness, everything orbits around it. When you know that, then when you look at the galaxy, you find the same dynamics. Right? This is a galaxy. This is a huge fractal level larger than a hurricane. A hurricane is a few hundred miles across. A galaxy is a few thousand light years across. Okay? And it has billions of stars in it. What's at the center of a galaxy? An immense black hole. The point of stillness. Singularity. The point where all spin cancels, creating non-movement, singularity. Yes, the black hole is orbiting, But that's the outside. If you go in towards singularity, further you go, stiller it's going to get, colder it's going to get. Now when I show this to people, when I showed this to physicists almost 12 years ago, I predicted from this theory that the center of all galaxies were going to generate black holes. That all galactic center had a black hole at the center. I got kicked out of physics conference for saying things like that. Well, recently, this data appeared. The largest Hubble the latest Hubble observations are presenting a cosmological challenge as astronomers uncover supermassive black hole at the heart of every galaxy they examine. That is a large prediction, you know. That is not trivial. Go ahead.
If you look at these pictures of the galaxy, you see that washed out thing in the middle?
Yeah.
Right? If you look through like a 10-inch telescope, you don't see that big washout. That's the film getting overexposed so they can see the outer edges. If you look at it through a small telescope, you can see a dot at the center of every one of these galaxies.
Yes.
And 20 years ago, I thought to myself the same thing.
Really?
And I started seeing that.
Oh, good. That dot you see in the middle of the galaxy is actually some of the brightest objects we observe in the universe.
And you never see that in any photos, ever.
Mm-hmm.
You can only see it through telescopes.
Oh, that's good to know. You know, and they call it a black hole. Yet it's the brightest object we observe. Why? Why? Because we're observing the external part of that black hole, not the internal part. Right? So, you know, that was interesting. Here, astronomers are left scratching their head, wondering how these objects, once seen as novelty items or the stuff of science fiction, may be commonplace, dominating the core of possibly every large galaxy in the universe. Well, they keep scratching their head. Previously, supermassive black holes looked like pieces of custom equipment added to a car, said University of Michigan, Now these look like standard features. And if black holes are an integral part of galactic formation, that could require a major revision of our theories. No kidding. Maybe you don't kick people out so easily anymore. So you guys see where I'm going? See, this is the concept that I'm bringing forward. Everything is centered by singularity. And everything that is outside that center is the radiated part that we observe as the universe, because it rotates. Because it has angular momentum, and that generates forces like electromagnetic radiation and so on. So when I was looking at all this stuff, and I realized that these lobes had to be those vortices that are moving through space, then I quickly seen that these vortices actually match the dynamics we see for the tensor equations of the electron clouds. The same dynamics are found at the electron cloud. These are the probability equations for electrons. And then I found subatomic particles follow these dynamics as well. Mesons are vector equilibrium. Baryons are isotropic vector matrices. And then I noticed that's extremely small, right? Then I noticed that in the extremely big, the same dynamics are found. These are supernova explosions here on the right, on your left. And this is a crop circle. When this occurred, I got really excited. I'm like, oh my God, they took a picture of the geometry of space. So I'm like calling my local astronomers and stuff.